Hello, this is Dr. Hanaa Assil, and this is the last part of the review on Modular Unit 2 for the IGCSE Chemistry at Excel. So this is the part we're talking about organic chemistry. Remember, I'm going to remind you that when we talked about organic chemistry, we were saying organic compounds are divided into groups, which we refer to as homologous series. And the members of the same homologous series have the same general formula, same functional group, similar chemical properties, and there is a trend in the physical properties. They're not similar and not the same. There is a trend in physical properties. So we already talked about alkanes and alkenes in Unit 1. We're now going to talk about alcohols, acids, and esters. I'm going to remind you again, how do we name organic compounds? We said we count the number of carbons. So if we have 1 carbon, the name should start with meth, 2 is eth, 3 is prop, 4 is but, 5 is pent. And then we determine which functional group are we talking about. Are we talking about something that has an OH? Then it's an alcohol, so ethanol. Or something that has this group, COOH, then it's an acid, so the name will end with oic acid. We have different types of formula, so if we're required to draw displayed formula, you draw it all out. Structural formula means each carbon you count the number of hydrogens that is attached to it. Molecular formula means the total number of carbons, total number of hydrogens, and whatever elements present. Empirical formula shows the formula with the simplest ratio. The general formula is where we use an N to determine the number of hydrogens or how many compared to the number of carbons. So, alcohols, we know alcohol should have the functional group OH. So 1 carbon is methanol, 2 carbons ethanol, propane 1 all, that means the OH is on one end. Remember, we said we count from the side that gives the lower number, so that compound is propane 1 all, not 3 all. If we count from the right, it is 1. Butane 1 all, if the OH is in the middle, that is butane 2 all, not 3 all. We count from the side that gives the lower number. Then we need to know how to prepare ethanol. Preparation of ethanol is very important, and we can prepare it by one of 2 methods. The first method is by adding steam to ethene. This process is called hydration. Conditions: phosphoric acid catalyst, 300 degrees Celsius, 60 to 70 atm. Please learn all of these. Now, where do we get ethene from? We get it from petroleum. You know that petroleum or crude oil is a mixture of liquids, so we separate this mixture by fractional distillation. This gives long chain hydrocarbons. Then we do cracking to change it into ethene. So ethene is produced from crude oil. One disadvantage of this method is that the crude oil is a non-renewable resource, and the other disadvantage is we need high temperature and high pressure, so this process is expensive. But the advantages of this process is it is fast. As soon as I add steam to ethene, I get ethanol, and the product is pure. Now, the other method of getting ethanol is from glucose. This method is called fermentation. So what do we add to the glucose? We add yeast, water at around 30 degrees Celsius. This changes the glucose into ethanol plus carbon dioxide. Now, where do we get the glucose from? We get it from sugarcane. So the advantages of that method is we get it from sugarcane. This is a renewable resource, and we don't need to heat to a very high temperature, so this process is actually less expensive. But the disadvantage is, first of all, it is a slow process. I leave the yeast with the glucose solution for some time before it forms ethanol, and the final product is a mixture of yeast, water, and ethanol. So I need to filter to remove the yeast, and I need to separate ethanol from water to liquids with different boiling points. So I need to get my ethanol by fractional distillation. So the advantages of the hydration is produces pure product, fast process. But the disadvantage was it needs crude oil, which is non-renewable, and it requires high pressure and temperature, so it is more expensive. The fermentation of glucose, this is obtained from sugar cane, which is renewable, and the temperature and pressure are low, so this is less expensive. But the disadvantage was it is a slow process and the product needs to be purified. So if we have a question like this, ethanol can be manufactured from ethene by reaction 1, or it can be manufactured from glucose by reaction 2. And he's saying give 2 advantages of each reaction. So reaction 1 is the hydration of ethene. Remember, what were the advantages? It's a fast reaction and gives a pure product. What about reaction 2? Fermentation. What were the advantages? We said the glucose is obtained from sugar cane, which is renewable, and we do not require high temperature, so it is less expensive. What about the 2 methods? Again, we said here he's saying method 1 is fermentation, method 2 is ethene with steam. Name the catalyst used in each method. What is the catalyst in fermentation? Remember, we said fermentation means I'm adding yeast to the glucose. Yeast contains the zymase enzyme. So remember that the catalyst in the fermentation of glucose is the enzyme in the yeast. The enzyme in the yeast is called zymase enzyme. That's our catalyst. Now, in the second method, the method of adding steam to ethene, what was the catalyst? We said the catalyst was phosphoric acid, H3PO4. Then we talk about reactions of ethanol. Of course, ethanol, like alkanes and alkenes, they do combustion. Combustion, if it is complete combustion, it gives carbon dioxide and water, and be careful with the balancing. The other reaction of alcohols is oxidation. If we oxidize alcohol, it gives the corresponding acid. So ethanol gives ethanoic, propanol gives propanoic, and so on. So what do we add to do oxidation? Remember, we add acidified potassium dichromate, or it is potassium dichromate with concentrated sulfuric acid. Remember that the potassium dichromate is originally orange. When it reacts, it turns from orange to green. We can also oxidize ethanol by microbial oxidation. This is oxidation of the ethanol by oxygen in the air. This is actually using bacteria, and this forms ethanoic acid. Then we need to talk about carboxylic acids. Remember, carboxylic acids contain this functional group, C double bond O, OH, so 1 carbon or 2 carbons or 3 carbons, methanoic, ethanoic, propanoic. This is how we draw it out in displayed formula. Remember that carboxylic acids are weak acids, so they have pHs about 4 to 6, and vinegar is actually what we call ethanoic acid, that is vinegar. So if he says what is the structural formula of ethanoic acid. Remember, ethanoic means I have two carbons. So this is the displayed formula. How do we write it as structural? We said we collect the hydrogens around each carbon. So this is written as CH3COOH. And this is how we write it in an equation. So if we have an equation involving ethanoic acid, I write it as CH3COOH. This question says write an equation to show what happens when ethanoic acid is dissolved in water. Remember, a normal acid when dissolved in water will give H plus ions plus the rest of it. So HCl gives H plus, Cl minus. What about ethanoic acid? Well, the H plus comes from the part that is COOH. So when we dissolve an organic acid or a carboxylic acid, it is the COOH part that ionizes to form H plus, and the rest of it is the minus. So, reactions of acids. Acids react with metals, just like the normal inorganic acids. An acid reacts with a metal to give the salt plus hydrogen gas. Here, what is the salt? Remember that the salt is removing the H of the acid and putting the metal. So sodium plus ethanoic acid gives sodium ethanoate plus hydrogen gas. This is how you write it in a structural formula. Also, if I'm reacting it, but remember that sodium valency 1, so we need CH3COO with an A. But calcium, what if I'm doing calcium? Calcium has a valency of 2, so each calcium needs 2 of the ethanoic acid. So this is the formula of calcium ethanoate. Reaction with base, remember any acid plus base gives salt plus water. So sodium hydroxide plus ethanoic acid, we said the salt in the organic acids is something OH. So sodium ethanoate. What about carbonates? Again, acids react with carbonates to give salt plus carbon dioxide plus water. So the acid, ethanoic acid plus sodium carbonate, for example, would give sodium ethanoate plus carbon dioxide plus water. What about reaction of an acid with an alcohol? You should remember a carboxylic acid with an alcohol gives an ester plus water. This is because we remove the OH from the acid. We remove the H from the alcohol and join them directly. What is formed is called an ester, and my other product is water because I removed H and OH. So if we have ethanoic acid with ethanol, first of all, remember that the catalyst for this process, which we call esterification, the catalyst is concentrated sulfuric acid. So we have ethanoic plus ethanol gives the ester. How do we name the ester? We start with the name of the alcohol. We had ethanol, so the ester is ethyl something. The acid was ethanoic, so the salt is, or the ester is ethyl ethanoate. How do we draw the ester? We start by drawing the acid. So notice that we drew the ethanoic acid on the left, C with 3 hydrogens, C double bond O, and then we continued with the part of the alcohol, the C2H5. Of course, the other product is water. So when we're reacting it, we remove the OH from the acid, remove the H from the alcohol, and join to form the ester. Again, if I'm starting with propanoic acid plus ethanol, again, the catalyst is concentrated sulfuric acid. How do I draw the product? I start by drawing the acid. This is propanoic, so I have 3 carbons, C double bond O, and then we stop and we add the H from the alcohol to give the ester. Now, how do we name the ester? We start with the name of the alcohol. Which alcohol did we start with? Ethanol. So the ester is ethyl something. The acid was propanoic. So the salt or the ester is propanoate. So esters are the ones that contain this functional group, C double bond O, single bond O something. So how do we name an ester? How are we going to name this ester? You should know the part that has C double bond O, that was the acid. The part that has the O, that was the alcohol. When we name it, we start with the name of the alcohol. So this is an alcohol that had 1 carbon, so methyl, and the acid had 2 carbons, so that is ethanoate. What about this one? Where is the acid and where is the alcohol? The acid is the one on the left with 1 carbon. The alcohol has 2 carbons. We start with the name of the alcohol. 2 carbons is ethyl. The acid had 1 carbon, that is methanoate. What about this one? Alcohol with 2 carbons, ethyl. Acid with 2 carbons, ethanoate. What about this one? The acid has 4 carbons. The alcohol has 2 carbons. Start with the name of the alcohol, ethyl butanoate. Esters are volatile compounds with fruity smell, so we use them as food flavorings and in perfumes. So the questions are something like this. He gives me the structure and he says, name 2 chemicals that could be used to make this ester and draw their structural formula. So again, where is the acid and where is the alcohol? Obviously the acid is the one on the left with 2 carbons, so that was ethanoic acid. The alcohol is the one that has the O, so that is something with 4 carbons, so that is butanol, and you should be able to draw the formulas of ethanoic acid and butanol. Write the word equation for preparation of the ester propyl ethanoate. So I want to make propyl ethanoate. Which acid and which alcohol? Propanol and ethanoic acid would give propyl ethanoate plus water. Draw the structure. We said you start by drawing the acid. This was from ethanoic acid. So you're starting on the left with an acid that has 2 carbons, and then you complete with the alcohol that has 3 carbons. Fill out with hydrogen so that each carbon has a total of 4 bonds. Write a word equation for preparation of butyl methanoate. Again, what did we start with to make butyl methanoate? We said the one with the O-weight, that was the acid. So that is methanoic acid. The one that is butyl, ethyl, methyl, that was the alcohol, so butanol. With methanoic acid, of course, forms the ester plus water. Then we need to talk about synthetic polymers. Of course, we call them synthetic because these are polymers that are made in industry. There are other types of polymers which are natural polymers. So you should know carbohydrates, fats, proteins. These are called natural polymers. But the ones we're going to be talking about are synthetic, which are made in industry. That you should know that the word polymer means large molecules made by joining many small molecules together. The monomers are the small molecules that can be joined with other small molecules to form a long chain unit. Please do not use the word we are defining in our definition. So don't say polymers are made of a long chain of monomers. Don't say that, because you haven't told me what monomers mean. So polymers are large molecules made by joining many small molecules together. The monomers are the small molecules that are joined together with other small molecules to form a long chain. The process is called polymerization. So this is the process of joining many small molecules together to form a long chain. And then, so what are the uses of polymers? Remember, synthetic polymers is what we call at home plastics. So what do we use them for? We use them to make plastic bags, plastic bottle, ropes. Don't say we use it for plastics. It is plastic. So what do we use it for? We use it for making plastic something, plastic bags, plastic bottles, and so on. So what are the problems or the disadvantages of the use of polymers? Remember, polymers are non-biodegradable, and this means they are not broken down by bacteria. So they are non-biodegradable because they are inert, so they accumulate in dump sites. So they are non-biodegradable, that means not broken down by bacteria. And this is because they're inert, so they accumulate in dump sites. The other problem is when burnt, they release toxic gas. So how do we draw polymers? Well, we have two types of polymers. If we're starting with a monomer that is an alkene with a double bond, this is called addition polymer. And when we want to draw the polymer, we look at the two carbons that have the double bond, copy them with a single bond, bond on the right, bond on the left to indicate that they are bonded to other units, and then we write whatever was present on each carbon. So for ethene, both carbons just had hydrogens. I copy the hydrogens. Now, how do we name the polymer? The polymer is always poly, the same name that we started with. So we're starting with ethene. The polymer is called polyethene, even though we're no longer an alkene. The polymer, notice, is an alkane, not an alkene, but the name is poly of what we started with. What if we're starting with propene? Again, we look at the two carbons that have the double bond. Please don't just write three carbons after each other. We join the monomers from the two carbons that have the double bond. We write it as a single bond, bond on the right, bond on the left, and we indicate that this unit is repeated many, many times. I don't know how many, so we write N. Then we look at each carbon. Each carbon was bonded to what? That carbon on the left was bonded to two hydrogens. I copy the two hydrogens. Now, the carbon on the right of the double bond was bonded to a hydrogen and a CH3. That's exactly what I write. Again, what is the name of the polymer? This is starting from propene, so this is polypropene. Butadiene, again, please look at the two carbons that have the double bond. Copy them into a single bond, bond on the right, bond on the left, bracket N. And then determine each carbon of the double bond was bonded to what? So the carbon on the left was bonded to two hydrogens. The carbon on the right of the double bond was bonded to a hydrogen, and all of that, C2H5. Again, that would be called polybutadiene. What about butadiene? Again, look at the double bond. Copy it with a single bond. Bond on the right, bond on the left, bracket N. Then, each carbon was bonded to what? The one on the left was bonded to a hydrogen and a CH3. The bond on the right of the double bond was bonded to H and CH3. Notice that the bonds going down are going to the carbons, not to the hydrogen. The bond, the line we're drawing going down there is between a carbon and a carbon, not a carbon and the H3 part, for example. Name of the polymer, poly, the same name we started with. Again, this is called tetrafluoroethene. Tetrafluoroethene, instead of having hydrogens, has fluorines. The same thing, the double bond becomes single, bond on the right, bond on the left, bracket N, and we just write what each of the carbons was attached to. Now, if we're not starting with alkenes, we're starting with something that has two acid groups on its end or two alcohol groups on its end, then this type of polymer is called condensation polymer. And that is because these two, we're going to join them together as if we are reacting acid with alcohol to give ester. So these will form a polyester. That means, first of all, that box in there just represents anything that you can have in there, because what we have inside the chain has no effect on us. So if we start with a box, if the question has a box, copy it with a box. If it has carbon, 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 whatever it is, just copy it as it is. All we care about is what is on the end of each molecule. So the diacid has acid groups on both ends, and we said when we form esters, this is just as if we're forming ester. We remove the OH from the acid, the H from the alcohol, and join. On the other side, we're going to remove the OH to join to another alcohol, and on the right, we remove that H to join to another acid, and that means my product is this, and this is what we call a polyester. C double bond O, box C double bond O, O box O. Now, if I'm starting with carbons, you just put carbons instead of the boxes. Remember that if he says draw the structure of a polyester or the structure of pterylene, pterylene is an example of a polyester, that is what you draw. And remember, we removed H's and OH's, and that means my other product is water. Again, this is a diacid with a dialcohol. So this is a diacid that has nothing in between the two carbons. So that's okay. I'm just going to copy as it is. Remove the OH, remove the H from the alcohol and join, and that is the polyester. That, remember, there is something called biopolyesters. Biopolyesters are types of polyesters that are biodegradable. Remember, we said the polymers we've been talking about are non-biodegradable, and we said that means cannot be broken by bacteria. But if we say we're talking about a biopolyester, now this is a type of polyester that is biodegradable, and that means it can be broken down by bacteria. Comparing between the two types of polymerization, we said if we're starting with monomers that are unsaturated, alkenes, this is addition polymerization, and the polymer is the only product. While in condensation polymerization, we're starting with monomers that have active groups on both ends. We remove the small molecules like water in order to join the monomers together. So if we have this polymer, what type of polymer is this? Is this addition or condensation? Of course, obviously, this is something that was made from acid and alcohol. This is a condensation polymer. And we said the part that has the C double bond O, that was the acid. The part that has the O's, that was the alcohol. So these are the monomers that were joined together to give that polymer on top. Okay, we have this, and he's saying draw the repeat unit of the polymer. How do we draw the repeat unit of the polymer? This is something that has an alkene, so we open the double bond, make it into a single bond, bond on the right, bond on the left, and close with a bracket and N. Please remember that that monomer up there is called ethanol, so this is actually polyethanol or PVA. A typical molecule of PVA has a relative molecular mass of 27,500. So my polymer that has many of these has a total MR of 27,500. Calculate the number of repeat units. So how many of these repeat units do we have in the polymer? Well, get the MR of the repeat unit. So the MR of one unit is 44, and that means we divide the total by 44. This gives 625 repeat units. And that's the end of all this review of Modular Unit 2. Good luck in your exam, and thank you for listening.